identity matrix. So the identity matrix is kind of like the one in a math, right? The identity is always just one. Everything goes to one. One is very nice when it comes to it. Okay. So in matrices, the identity matrix looks like this, which is something we already talked about before, right? Believe it or not, huh? Interesting. So I, we call the identity, is a matrix 1, 0, 0, 1, or a 3 by 3 is just the ones on the diagonal, and everything else is just a set of zeros. Okay. So that's the identity matrix itself. Okay. All right. The reason why we care about that is when it comes to finding the inverse, or we're going to do it in two different ways. One way is very nice. That's going to be a 2 by 2, which is so special. The next way is going to do a 3 by 3, which is a little bit more complicated, but still kind of doable. Okay. So inverse of a matrix. So let A be a matrix, then A with a -1. So this is kind of the same as this when we did inverses, right? It's not to negative power, it's just the notation of it, is the note of the inverse of A such that, and this is a key thing when it comes to inverses, if you multiply A times its inverse, you get the identity matrix back. Meaning when we multiply both matrices, so basically like the stuff we just did, and the result is exactly this, they are actually inverses of each other. And it doesn't matter, believe it or not, which way you multiply it, which is actually even more interesting. So you can do A times its inverse, or inverse times A, you will get the identity property back anyways, which is pretty cool. Okay. So the question now becomes, how do we find the inverse, which is the most important thing, and then figure out what we do from here. Okay. So when it comes to a 2 by 2 matrix, so this is, just do this for example. So for 2 by 2 matrices. Okay. So in other words, say matrix A is A1, A2, A3, and A4. A inverse, or the inverse of A, is equal to 1 divided by the determinant of A times, okay. Now this is cool. We're going to swap places and just pop a negative in front of those. That's how we do the inverse of a 2 by 2 matrix. So again, we're going to find the determinant of this. That's that portion. We're going to swap these numbers and just pop a negative in front of those two. Pretty crazy how that works out. So that's why 2 by 2s are actually not that bad, because it follows that nice template when it comes to it. 3 by 3 is a little messy, but that's that portion there, right, when it comes to it. So for example, let's suppose matrix A was a matrix 5, 2, 8, and let's say 7. So first off, when we want to find the inverse, we need to find the determinant of A. So going back a section. So remember the determinant of A, if you guys remember, is 5 times 7 minus the other way. So this is 5 times 7 minus 8 times 2. So this is going to be 35 minus 16. What does that give us? Is that 17, 18? Oh, 19. So the determinant is 19. So therefore, A inverse is going to be 1 over 19 times our matrix. And again, we're just going to swap these numbers. So now it's going to be a 7 here and a 5 there. Literally just swap the numbers and just pop a negative in front of them. So it'll be -2 and -8. And there's your inverse. Now, in most cases, usually you want to put this number in here. So, and it's not too bad. You just leave it as a fraction. 7 over 19, -2 over 19, -8 over 19, and 5 over 19. If you want to leave it like that. Again, this is always going to work if we have a 2 by 2 matrix. So, question now is, how do we know if it is true, right? Like, if you're doing homework or an exam, how do you know this actually works out? Well, there's your key. If we multiply a times its inverse, we should get this back. So let's see if it actually does work out. So does, let's say a times its inverse equal I? Right? So are the actually inverses of each other? So let's actually multiply. So first one this way. So it's going to be 5, 2, 8, and 7. And you're probably already thinking, great, we have to deal with fractions. But don't worry, it actually comes out pretty nicely, if this is correct. That's the best part. If it's not, then you get horrible numbers. But if you did the inverse correctly, the fractions actually all go away. Okay, so it's a 2 by 2, 2 by 2, so it's not too bad. Remember? So it's going to be this times this. So remember, just multiply top. So 5 times 7 is 35 over 19. Are you guys comfortable if I just quickly do that multiplication instead of just writing it out? Everybody good there? Just quickly skip a step. Okay. Plus 2 times -8, so that's -16 over 19. Okay, next one. 5 times 2 is -10 over 19, plus 2 times 5 is 10, again over 19. And notice, look at that. I already get that 0 there. Down here, 8 times 7 is, what is that? I don't even know. That's bad, huh? 56, okay. 56 plus 7 times 8, so that's negative, oh, it's exactly 56, so -56. And then it's again, get that 0 there. Okay, -16 over 19 plus 35 over 19. And now we just simplify and see what we get. Hopefully we get the identity matrix, right? All right, so 35 minus 16, that gives you 19. And then 19 divided by 19 is 1. Aha, look at that. We're good there. This is just 0, even better. That is just 0. Cool. Almost there. And then this is the same process. That's also going to be 1. So it works out. It does actually work. And this is the way to verify, are they actually inverses of each other? Any questions so far? Everybody comfortable? Okay. Let's just try a couple more inverses then. And same process. Let's find the inverse. All right, so first thing is we got to find the determinant of A, right? Because that's the portion. Determinant of A. So this is, well, that's going to be 0, right? 0 minus. That's also going to be 0, so it's going to be 0. I guess that's pretty sad. Okay. All right, so our A inverse is going to be 1 over 0 times. So we're going to flip these around. So it's going to be flipped and then pop a negative. So -4, well, doesn't matter if you put a negative, it's still going to be 0, right? When it comes to it. So is that our answer? Ooh, I think I tricked all of you. Well, here's the thing. Is this possible?
No.
No, you can't have a 0 on the bottom of the fraction, right? And you can't, it's not even 0. Remember, it's undefined. Remember going back to vertical asymptotes? They have a slope of 0 or undefined. So therefore, this is actually incorrect. This has no inverse at all. And again, the reason why is because you can't, you can't have a number over 0, right? You can divide a pi into, when you have nothing when it comes to it. So that's the one situation where you won't have an inverse, or basically when the determinant is equal to 0. Any questions there?